All right, I'm giving. We've got 6.4 and 4.4 factoring. That's the older stuff. That's retake material. How about if, okay, number 4. Number 4, I have an exponent outside parentheses. So I'm going to multiply to that exponent first. So I get all of this stuff inside. I get x to the 0, y to the negative 3/5 raised 2 times 1/2. What's half of 2? 1. Now I have to distribute these exponents, which equals x to the 0. 0 times 1 is 0. Y to the negative 3/5 times 1 is negative 3/5. I can. You guys are still doing this. There are still a couple of students leaving negative exponents in their answer. I can't give you full credit for that. Sabrina. What's that? Two times 1/2 is 1. Yep. X to the 0 is 1. Anything raised to the 0 is 1. And then I have to put y to the 3/5 in the denominator. Another big mistake that you guys are still doing. No. Because you were supposed to have this done when you came in today. Number one, I'm going to multiply my numbers. I get 90. The x's I'm going to add the exponents, not multiply them, add them. Stop it. You guys are still multiplying them. Negative 2/3 plus 2. And then the y's. I don't care. You're going to add the exponents. Quit multiplying them. So I have 90. What's negative 2/3 plus 2? And what's negative 5 plus 3/5? Okay, so it's going to go in 22/5. There you go. These really aren't that hard, you guys. For some reason, you keep multiplying exponents for everything. I don't know why. Okay, number 3. Now, 14 does not divide evenly by 28. However, don't multiply 14 and 28. Don't subtract 14 from 28. Don't add the two together. Reduce it. What's 14/28 reduced? Yeah, 1/2. Okay? Not 1 over 1/2, not 2 over 1/2, not 2 over 28, not 28 over 14, not... you would not believe the answers I get from you guys. 14/28 reduced is 1/2. Okay. Now, x to the negative 2. And since I have division, what do I do with the exponents? Subtract them. So I'm going to subtract negative 2/3. Watch your signs here. Okay. X to the negative 4/3, is that what you get? So where's that going to go? All right, the y's. I got y to the 1/4 minus negative 3/4. This one I can do in my head. What do you get? Y to the 1st, which goes in number 2. The first thing I have to do, I got to, like everything else we do in math, parentheses, right? I have to distribute, is that 5/2? To each one inside the parentheses, not the x to the negative 1/2. So I'm bringing down the x to the negative 1/2. Okay. Now, 3/5 times 3. And y to the... Okay, now I've got multiplication between the two, right? So now what am I going to do with the exponents? Add the exponents. Okay. So I've got... I don't care. You put 1 there, you could just leave it off too, if it's not holding a place. So x, negative 1/2 plus 15/2. If you're taking away 1/2 from 15/2, we're adding. You should get 14/2, which is 7. Negative 1/2 plus 15/2. Put it in your calculator. Let's see. Negative 1/2 plus 15/2. 7. X to the 7. You know what I always say, if the shoe fits. 5, 6, and 7. What's radical form?
Mr. D, why would you say 5, 6, and 7 but move all the way down to 8, 9?
What are you talking about? 5, 6, and 7. Radical form. Index. Base. Exponent. Rational exponent form. Base. Exponent divided by index. So, b to the 5/3, change it to radical form. Here's my radical. And my base is b. My exponent is out here, which is the top 5. My index is 3, goes in the root. Radical x7. Now, this does not equal x to the 7 over 1. It's x. Hey, I guarantee I'm going to write this on like a half a dozen papers. This is squared. Okay? There's a 2 here, not a 1. Schmucks. Number 6. Thankfully, everybody kept their cards, right? The yellow ones. These, you're simplifying. Simplify. It says simplify, I say. Simplify. So you're going to need 2 radicals, the perfects, like math teachers. And then you've got the imperfects, like students. I'm not saying. Okay, the highest perfect square that's a factor of 32. 16. 16 times 2. What's the highest perfect square? X to the 7th. X to the 6th. That leaves me 1x left over for the student side. What about y to the 4th? How many perfect squares? 4. None to put in the student side. What about z to the 3rd? I can take 2. 2 divided by 2 is a whole number. Gives me 1 left. What's the square root of 16? What's 6 divided by, remember there's a 2 there, not a 1. What's 6 divided by 2? What's 4 divided by 2? What's 2 divided by 2? The students stay exactly the same. They never change. 2 of them. I think I might just read it to you. Okay, here I have 4th roots. Okay, perfect and imperfect. What's the highest perfect 4th root that goes into 16? Look at your card. 4th root. 2. Okay, what about how many 4s are in 12? 3. B to the 8th? I could take all 8 because 8 divided by 4 is 2. What about C? Yeah, I could take all 4 of them, get C to the first. Guess what? This guy's life is like heaven because there's no students. Let's go over some factoring. What do you have to do before you start any factoring problem? The fourth root of 16 is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Fourth root, 4 times. Yeah, that's exactly what it is. What do I do before I start any factoring problem? You guys have a flow chart you can use on the quiz tomorrow, right? What's the first box say? No, it's not the first one. Wow. Factor out any common factors. Do I have any common factors in number 8? Yes. There's 2. 2x squared divided by 2 is x squared. Negative 16x divided by 2 is negative 8x. 40 divided by 2, 20. You wouldn't believe the strange answers I get. Just bring that 2 throughout the whole problem. Okay? There's only one way to get x squared. It's x times x. 20. I need 2 numbers to multiply to negative 20 and add up to negative 8. That's a minus sign, so one has to be positive, one has to be negative. I want the bigger number of the factors of 20 to be negative. I'm going to use 10 and 2. How about number 9? What do I do first? Skip it? Yeah, factor out an 8. Good, Sabrina. X squared minus 9. Okay, now, Jacob. What kind of problem do I have here? A binomial. I'm factoring a binomial, not just any old binomial. I have a difference of squares. Okay. Think of this as 8 times x squared minus 3 squared. Okay. So I have my 8. Don't put the 8 inside any parentheses. Just keep it outside. I have an x for a base. My formula says plus minus. And my other base is 3. That's it. Let's do a domain and range. Number 12. It says, give an example of a set of points that is not a function. What makes a graph not a function? vertical line test, right, Dakota? You got an answer? Real easy way to do this. Pick some points. Okay, I'm going to pick 4, 2, any old points, I don't care. 0, 1, and then here's what you do to make it not a function. Pick the same x and give it a different y value. That makes it not a function. Okay? I have the same x, the same input, with 2 different outputs. Okay? I have the same x with 2 different y values. Makes it not a function. What? I've made them up. You're going to have to make them up too. So what's my domain here? Actually, this should go here, right? Why is this not a function? What's my domain? My x values, right? And the range, my y values. All right, that's enough. Keep going. 13. Create a function on the graph. What is it? Huh?
Can you put this on Google Classroom?
I sure can. And you know what? Why don't we just do an absolute value function since we're working with those? My domain, negative infinity, positive infinity. Range, 0 to positive infinity. On the x-axis. Yeah, it doesn't matter. I'm just getting the domain and range.